and welcome to the Backyard Machine Shop. Well guys, we're back working on the shaper. I've been working on it for almost 2 weeks now. I've taken it completely apart, derusted most of the parts, did a bunch of checking and trying to figure out what needs to be done to it. And this is what this video is going to be about. Basically, it's going to be a little short video to show you how I've been digging into this thing and what I've discovered that may be wrong or that may need some repair. So what we're going to do is I'm going to bring you in close and try to get you to where you can see what I've got here, and I'll explain what's going on. You're looking at the main casting of the shaper. Now this is where the ram rides back and forth. The crank pushes the ram back and forth in here. So I got to noticing when we took it apart, there is some wear lines in here. There's one here, and then there's one here. So when you're doing work like this, you need to find places that aren't worn, and that'll be your datum for the remainder of the part, or checking the remainder of it. So there's a couple of surfaces in here is what I'm thinking have not been worn. One is this surface right here. This surface is where the gib is that actually pushes the ram over against this wall. So I'm thinking that this surface is a non-wear surface and this surface is a non-wear surface. So to verify that, I did a couple of things. One, I measured the thickness of this machine surface here. I just squeezed it with a pair of mics all the way down, and I just did it every hole. So whatever that space is, but right around every hole I measured it, and it come out to be from one end to the other. I hit 1 inch 278, three spots, and then right on the back was 1 inch 279. So you're a thou in this whole side here, different from front to back. And so that verifies what I was thinking, that this is a non-wear surface, and that it because of the gib being there. Also, I measured this side, and this side actually did pretty well also. It was I think within 0.02. I can tell you. All right guys, so we measured this side also, and this side was 1 inch 383 here, 1 inch 385 here, and 1 inch 384 here. So basically it showed that it was pretty much the same thing too. So the next thing I did, also I know this surface here is a non-wear surface, and it's a machine surface, so it should not have changed much over the years, because it doesn't have anything wearing on it. So we know, so then we can, with knowing that, we know we can measure from here to this surface. It should be non-wear, or a virgin surface, or an original surface, and we can tell how much wear is in our machine. So when we measured that, we measured from here, to this surface right here, and we were 989 thousandths. All the way back, 989 to, I'm sorry, 988 to 9, this last one was 984. So all the rest of them were 988, 987, or 986, and 984. So we had a little bit of a difference in here, about 2 thousandths. And again, you're talking about 1880s machining. I'm not sure how accurate they could be at the time, but that to me, that's pretty good. All right, with that surface being known, we come back and then we measured from this surface to this wear surface. Now there's a little bit of a lip on this inside too, so I know this is where it has worn. So when we measured it, we got 1 inch and 6 thousandths, 1 inch and 4 thousandths, 1 inch and 3 thousandths, and 1 inch and 3 thousandths. So that's telling me that there's roughly 22 thousandths wear. At least that's what that step is right here. Now, it wore even. I mean, it's worn within 0.003 front to back, and still, that's not bad. But it's worn. It also, it tells you that you're on the right track, because this is the most worn area in the whole shaper, and it's showing signs of that. Okay, so then we come over and we measure from this surface to this surface, and that give us 1 inch 8/1000, 1 inch 6/1000, 1 inch 4/1000, and 1 inch 5/1000. So we've got basically the same wear on both sides. Now this side's a little more than this side, and that might be because of when the shaper is running and your tool pressure, I think it'd be down in the front and to this side, because your bit's pulling into the meat. So that would be, I would think that's where your most wear would be. So everything that we've looked at here is showing us what it's giving us the details, and they're looking like that's what is going on. So it's kind of revealing itself. All right, so the next measurement we come in and took, we wanted to see this measurement from this side to this side. And we used a set of inside mics, and we measured these. Now, we measured on this front one, we were 7 inches 877 thousandths, 7 inches 876 thousandths, 7 inches 875 thousandths, 7 inches 877 thousandths. So now this side, like I said, this is a wear surface, but you remember when I told you the wear was about 0.003 in here? You had like a 0.003 taper in here. This shows you basically the same thing. You're 76, 75, and then back to 77. So your taper is right in here. Your most wear is right in here, but we're within 2 thou of being not consistent all the way through this area. So if you ask me, that's pretty good on that surface. And there's a little bit of wear. You can feel it right in that. There's a little tiny lip there to let you know that it has worn. So I'm happy with the measurements I have. Now, there's some options we can do with this, and we'll talk about them later. So now I'm going to take you over to my surface plate, and we're going to look at the ram itself. And the ram itself has been puzzling me a little bit, and so I want to give some details on it, and maybe we can, some of you guys out there that's got shapers or have worked on them before, maybe can answer some of my questions. Okay, hold on. All right, guys, so I got you over here, and we've got the ram set up on our surface plate here. Now, first thing I needed to do was I need to determine, since there's some wear in there, we need to find out how good we are as far as a reference surface. So I've referenced this surface, and I'll show you what it is, and then we've referenced this surface. I come in and I squeezed this ram here, the weigh, in 5 places, and the results were kind of not understanding them. I did the same thing on this side. Now, this side, my writing is going away, or either it's on the other side of the ram, and I don't know if I can let you know, but on this side, on the very front of the ram, we're at 957 thousandths. The second measurement, which is about 6 inches back, is 955 thousandths. And then we go maybe 8 inches at 955, at 956. And that looks really good. So we only have a 2 thousandths dip inside of these two measurements, and we're back to 956. Now, here's the puzzling thing. We come all the way out to the very end, and we're measuring 967 thousandths. Okay? So, and on this side, if I remember correctly, it was just about the same, but there was like 960. So it's like a 5 thousandths difference in the wear. And if you remember, in the casting, the main casting, this would be the side that had the least amount of wear, and this would be the side that had the most. All right, so what the next thing I wanted to do was, and I'm going to slide this thing a little bit forward. And what I have here is this is the thinnest shim that I have. Okay, this is a 1.5 thou. Okay, and I'm going to go along, and I'm going to try to find a spot where we can stick that 1.5 thou shim in. Well, there's one right there. Okay, I mean, it just barely goes in. So I have a 2/1000 shim here, and it goes in. And let's see what else we got. Have an 8. None of those will go in. What's this one right here? I don't have my feeler gauges with me, so I can't use those. Let's see. Well, I'll tell you what, let's stack the 1.5 thou into 3 thou, and I bet you it won't go in. Nope. It won't go in. So we got back to the 1.5 thou. We got one spot, if I can find it again. I mean, it's just, there it is, right there. There's a little area about 1 inch long that it will go into. Okay, so that's for 1.5 thou, and 2 thou will go in also, and maybe a 1/2 inch area. So we're going to keep continuing down. We still can't go in. All right, so that's telling me this side's pretty flat, and that this one right in here we have a little over 2 thou for just a hair of it. So I'm going to walk around to the other side and we will measure it. All right, guys, so measure from this side. I'm going to take the same 1.5 thou shim. All right, it's got a little sticky there. Still won't go in. Still nothing. Okay, so we got one area that's got a little bit of a rise in it, which is right in this area, right in here, and it's about 1 inch long. So now what I'm going to do is I'm going to push the ram back to where it's resting more on the front. My table is not quite big enough. And so then we're going to check to make sure the front's not high in an area. So we'll come back and do the same thing. Nothing, 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 nothing. Oh, we got a spot right there. Okay. Oh, little spot right there. Little spot right there. All right. So let's go with the 2 thou. We know what was right in here. That went in just a hair. Just a hair, just a hair, I mean, it's just barely. All right, so we're in right there, but I guarantee you that the 2 of them won't do it. So we're at 3.5 thou. Yep, so again, it seems pretty flat, and I'll go around and check the other side the same way. That one little spot that was sticky before is sticky again. All right, so we got 2 or 3 little places here with the most deviation of 3 thou, and really and truly it doesn't even go all the way in, so that's just on the outer edge of the ram. Now, the next thing I did is I come in with my height gauge, and I I verified all these numbers. We're at 957, and we can do that on this other side. So I told you the numbers here. We'll go over there and verify those numbers. Okay. All right, so our first measurement, we're going to measure right here on this end. Okay, so we're at 964.5 or so. Well, let's make sure we're at 0 on our. All right, so we're at 0. I moved the dial, guys. Let's lock it down. All right, so 962, and that's what I remember getting. 963. 964. 964. 965, and I'm gonna have to slide the ram forward to measure the end. All right, 968. And that matches this side over here, 967, 968. Okay, so, all right, the next thing we're going to do is we're going to check, we're going to put our indicator up here. Now I probably need to change this indicator for this, but I've got this 2-inch one up here because I was reaching around this stuff and trying to do it all from one side. So what we're going to do is we're going to set our 0 right there. Come around and look. Unload it. Come back to 0. Okay, so we're going to just try to drag it around to there. All right, let's put our 0 right there. All right, guys, can you all see that? All right, so now we're just going to slide it back. Well, I'll tell you what, let's turn this way, readjust our 0. We're going to slide this down. All right, so we slid that down the full length of this surface. Now this is a machine surface, and this would be a qualifying surface because this probably has the least wear of any of it, because there's a bolt that comes up here and it locks the mechanism that drives the shaper. So we're looking at 3 thou, negative 3 thou on the front, and we're measuring it on, if you roll it around, if I ain't mistaken, it's going to be like 1.5 thou, okay? So these two are kind of virgin areas also because they hardly ever get used. That would be both extremes of the shaper. So we got 1.5 thou right there. Okay, so now we can just bring the shaper back, bring the ram back up a little bit. Now I have a tip on this thing that will ride over some of these pitted areas where that shaper was exposed back in outside. So we're going to come in now and we're going to set it up right here on this way. Let's adjust it to 0. All right. So now what we're going to do is we're going to go to, we got a 0 in the middle. And if you remember, we were about 2/1000ths worn in the middle on both sides. So we're going to push it all the way forward. We should see 2/1000ths climb, or a +2, back to 0, and then a +7 or so in the back. All right, so we'll slide it forward. And there's your +2. Okay, and I'm pressing down on it. It ain't coming out. It's set. So now we're going to slide it back. Back to our 0. And then we can pull it. And you remember it climbed when I give you the measurements. It was climbing back here. Now it's hitting that area that was exposed, and it's got some pitting in it. And whoop, here we go. So we're about 10/1000ths in the back. Okay. So let's slide it up back to 0. All right. So now we're going to move over to the other side. And we want to set up roughly in the middle. Adjust our 0. All right, so can you see that? All right, let's zoom that in there. All right, I'm going to try to stay out of your way. But I'll tell you what, I'm in the wrong position for that ram. Okay, so we're going to slide it to the front. You remember we're 2/1000ths thick, 2/1000ths thicker up front. And that's hanging right at 0. I'm trying to go all the way to the front, and it's going to be the 2/1000ths. So we're about 1 thou actually. I'm going to slide it back. Back to our 0. Okay, and then we're going to try to go to this other end. And this end's going to be just about the same as the other. It's going to have probably 10/1000ths right on that end. Okay, right at 10/1000. You've seen that how we measuring it, and it looks good. It looks like the wear is actually on the top, or the machining of it was a little sloppier on the top. Now, 10/1000ths wear down here, I mean, it may be that much. So we got to figure out what to do with that. All right, so the next thing we need to do, and this is what's been throwing me off now, I'm gonna throw this back a little bit, move the camera back. All right, guys, so our next thing is, when I was setting all this up, originally I wanted to plumb this, make this 0, and then I can tell where the wear is. Well, I had a surprise waiting on me, because this is not at 90 degrees to this. Now, thought about, well, this has got worn. I'm going to show you how much difference there is. If it was just a few thousandths, I could say that, because it's showing that there's some wear in that direction. But not as much as that this is out. So what I've done, how I checked that, and I don't have a nice granite square or anything like that, so I can't. I'm having to do it the best way I know how. And so what I've done is I've got, let's see, couple parallels. Okay, and I laid them up here. Give myself a surface. Now, are these parallels perfect? I have no idea. But I can tell you this, they're closer than what this thing is showing. All right, so we got that. Clean our block, and we're going to set our block right here like this. Now, how we're going to measure this is I'm going to go get some gauge pins. Alright, so we got a set of gauge pins here. Now, what I'm going to do is I'm going to take the 250 gauge pin and verify that it's 250. Maybe it ain't. My glasses. Alright, so I got a 250 gauge pin. It says it's 250. So we're going to verify it. If I can read it. Alright, so there we are. We're at 250, dead on the money. I hope you can see that. Alright, so we're going to stick this 250 gauge pin back here, and we're going to push the block up against it. Now we got a space. The reason I did that was this little riser is actually proud of this face. Also, I need a way of measuring. So I'm going to slide the 250 in there. All right. And so what we're going to do is we're going to come along and we're going to measure the top. Now, I used the 250 mainly because I knew which way it was out or which way it was different. And so I'm going to start with 250. And I also know about where it's at. So we're going to come in here with a 228 pin. We'll verify it, and yeah. All right, so we're 228. Can you see that? All right, so the 228 pin, with some pressure on it, will slide in. Okay. So we're going to go to a 231 pin. So we got the 231 in. Let's check it out. And that's where we at on that, 231. And it will not go in. So 228 went in, 231 didn't. Let's get in between them. My guess is going to be this 229 here. So push it up just a little tight. All right, so 229 won't go in, and we already checked 228, and it will. So I know that the bottom is 250, the top is 228. That's 22 thousandths taper in this. I'm going to calculate that out. I think it's somewhere around 1 degree of taper, or this is at 89 degrees. Well, actually, I guess that might be 91 degrees, however you want to look at it, to the top. So what I need to know, guys, is should I put all the pins back in? 250. So what I need to know is, guys that's got shapers and have worked on shapers, is that the way it's supposed to be, or should it be at 90 degrees? I just assumed it was 90 degrees. All right, so there you go. That's what I've looked at. There's some other stuff that I've been measuring, and you know, it's just rough measuring. So I'm going to take you back over to the shaper. Hold on. All right, guys, that's about it. You see where I'm at with the shaper. I'm trying to figure out what I want to do with it. The right thing to do would be come in here and do a bunch of machine work to it, scrape it all in, and that's really what I want to do. Financially, that's going to be hard for me. One is because I can't machine. At least I don't think. I might can rig up something to machine this casting. So that's going to be an expense. The next expense is I still haven't collected all the tools I need to do scraping. And so I'm trying to collect them. So it may take a while to get to that point if we decide to do that. I need anybody that might know the answer for that ram, whether or not that tilt, that angle that it's sitting at, is that correct, or should it be 90 degrees? There's a lot of you guys out there that's worked on shapers. There's a few of you out there right now that's working on shapers and have them rams apart. And maybe one of you guys can check it and see what yours is. Next, what are we going to do with it? Well, we still have to build, do all the machine work. We got to pour a Babbitt bearing to replace a bad bearing in it. We got to check the bearings on the main drive. We've got to work on the jack shaft and the line shaft, and we have to figure out how we want to power it. All that's way off. I mean, I want to get the shaper back together and in good shape and ready for that before we start working on that. So, with all that said, guys, thank you for watching. Thank you for leaving the comments. Thank you for hitting the like button. The site is growing, the channel's growing, and I really appreciate it. So keep it up, and I'll keep working on it. So from the Backyard Machine Shop, so long.